There is not much difference between the no partial discharge test device and the ordinary withstand voltage test device in terms of function, but it has special requirements in production. Its main feature is that its partial discharge is very small, about 5 pC. This instrument is generally not used for withstand voltage test of high-voltage electrical equipment, because the price of this equipment is several times that of ordinary test equipment. The cost-effectiveness of using it for withstand voltage test is not high. The main purpose of this system is to cooperate with our company's partial discharge detector to boost the partial discharge equipment to be tested. It is reflected in the test as a source without partial discharge. This control box is the same as the ordinary control box. For specific use, please refer to the operation of the ordinary test transformer control box. Then let's focus on the wiring. This instrument consists of a pair of outputs, a pair of meters, a pair of inputs, and a ground. This pair of inputs is used to power the instrument. Just connect to a 220 volts power supply. The output of the control box of this instrument is connected to the input of the test transformer. But here, this output is to be connected to the input of the isolation transformer. This meter is to be connected to the instrument end of the test transformer without partial discharge. This ground is connected to the ground of the test transformer. Or it can be connected to the ground of the isolation transformer. Then use a ground wire to connect to the ground. This is an isolation transformer, and its structure is also very simple. It consists of input, output, and ground. This input is connected to the output of the control box. The output is connected to the input of the transformer without partial discharge. Compared to the ordinary test transformer, it adds an isolation transformer between the output and the input of the transformer. It has no transformation ratio, and its transformation ratio is 1:1. Don't worry about it affecting the voltage. It only plays the role of isolation and filtering in our entire partial discharge test. Then the grounding is grounded. This is the no partial discharge test transformer. Its input is connected to the output of the isolation transformer. The instrument is connected to the instrument end of the operation box. The high voltage tail is connected to the ground end. Ground the instrument. Before connecting this line, you need to assemble this set of no partial discharge test transformers and this coupling capacitor through a protective rod. Then this thing is equivalent to connecting the current limiting rod to the upper end of this no partial discharge test transformer. Then through a coupling capacitor. The tail end of the coupling capacitor passes through such a sampling box. Connect the tail end to the primary start of this detection impedance. Its primary end is grounded. There is a digital amplifier on it. It is connected back to channel 1 or channel 2 on the back of the JFD 2000A device through a coaxial cable. It depends on which channel you choose. This detection impedance is provided by the JFD 2000A device. It does not belong to this complete set of no partial discharge booster device. There is also a correction pulse generator here. It mainly provides a correction square wave. That is to say, the JFD 2000A partial discharge instrument needs to be calibrated before testing. It has a calibration operation. Calibration is required before each test. The output of this place is a red and a black. This signal needs to be clamped at both ends of the coupling capacitor. Connect its red wire to the upper part of the coupling capacitor. That is, the top of the high voltage. Connect the black wire to its lower part, because the coupling capacitor and the detection impedance are in series. Just connect it to its primary end. If you don't connect it here, you can connect it there. We connect it here for convenience. The bottom shell under this coupling capacitor also needs to be grounded. Don't forget this, many people tend to forget this step. the instrument's detection impedance and calibration generator on its non-partial discharge source and non-partial discharge source have been completed. A special reminder, the correction pulse generator only works when doing calibration. After the calibration is completed, this correction generator needs to be removed when doing the test. Otherwise, it will destroy the correction pulse generator during the boost process. This is the partial discharge tester of JFD 2000A. And this is a synchronous voltage. The red and black wires of this synchronous voltage can be connected to the instrument end of the control box. Connect the two wires together. At this time, you can adjust its transformation ratio on it. Then display it. Let the instrument synchronously display the voltage when the instrument is boosted. If you don't need it, you can leave it unconnected. It does not affect the test. This is grounded below, and a grounding wire is used for grounding. This channel is connected through the detection impedance. There is no problem connecting to channel 1 and channel 2. They have the same effect. It just means that when you use the JFD 2000A software, you have to correspond to channel 1 or channel 2. After the instrument is powered on, this interface appears. Open the test software. There is a new template here. The template name, location, etc. in the new template, these do not affect the test results. First select a template. And then you can connect to this interface. It means that the instrument is connected to the detection equipment and the detection impedance. After the connection, it can be automatically calibrated. But before calibration, the detection impedance needs to be turned on. Generally speaking, the requirement is to calibrate 50 PC. Now turn on the calibration pulse generator. After turning on the 50 PC calibration pulse generator, here, you can see that it has a prompt for calibration. Just click on the calibration. Now the software is fully automated. You don't need to calibrate yourself. If the calibration is too large or the error is too large, you can calibrate it several times without worry. Sometimes it will adjust the problem by itself. After the calibration is successful, it will have a prompt. Click OK. After the calibration is completed, it will automatically save. At this time, it means that the 50 PC calibration of the entire instrument has been completed. Turn off the pulse generator, and then remove the calibration generator. After removing it, check the background. If the background is qualified, you can test it. Remove it below. This is the process of removing it now. At this time, this place shows the discharge amount called background in the current environment. There are requirements for the discharge amount of the background now. First of all, for general equipment, the instrument requirements are basically below 10-15 PC. For example, if the test data required by our customers is that the partial discharge of this equipment I test is below 10 PC, then at least the background noise must be less than 10 PC. That is, it can be stably less than 10 PC. If you want to test a 10 PC product, its qualified range cannot be above 10 PC. If the background is 20 PC or 15 PC, it cannot be tested. Because the current background partial discharge is already greater than the partial discharge to be tested, it must be reduced. If the partial discharge is not qualified now, we can change the background through power filtering, grounding, independent power supply, independent grounding, and even through the construction of a new shielding room and other means. The purpose of changing the background is to make the entire device meet the use requirements. What are the use requirements? See here. After the calibration is completed, look at the background here and see what the background value is. At present, the background is too large and does not meet the requirements. We are just doing a demonstration now. Assume that the entire background is qualified now. We can start the boost device of the instrument, no partial discharge. And then boost the voltage, boost the equipment. See how much partial discharge the equipment has. Now let's demonstrate the boost. First increase to 5 kilovolts. At this time, there is a voltage display here. When the test calibration is completed, and the background noise of the partial discharge also meets the requirements, we can boost the voltage of the test product. The wiring of the boost is similar to that of the ordinary withstand voltage. For specific operations, customers can consult us when using this equipment. We need to analyze in detail how to wire the specific equipment. Thank you for watching.